All right, let's get into it. Today, we're going on a cosmic detective mission. We're talking about NASA's incredible hunt for the ghosts of ancient life on Mars. You know, this is the one question that drives everything. Every single rover, every satellite, every mission to the Red Planet is really trying to answer this. Was Mars ever home to life? So let's set the scene. Billions of years ago, Mars wasn't the cold, red desert we see today. Not at all. It was a blue world. It had deep lakes, it had flowing rivers. Basically, it had all the right ingredients for life to get started. So what happened? And where did all the evidence go? Well, that brings us to the biggest plot twist in this whole story. It turns out the very ground on Mars, the soil itself, has been hiding a secret that literally destroys the clues we're looking for.
Okay, so here's a really important thing to remember. We're not looking for fossils of Martian T-Rexes or anything like that. The clues we're hunting for are way, way smaller. They're called organic molecules. These are the complex, carbon-based molecules that are the fundamental building blocks of all life as we know it.
And here is the giant problem scientists ran into. See, the normal way to find these molecules is to scoop up some soil, pop it in an oven, and heat it up. The heat should release the organics as a gas you can analyze. Simple, right? Wrong. The soil on Mars is packed with these bleach-like chemicals called perchlorates. And when they get hot, poof, they release oxygen and just incinerate the very clues you're looking for. It's like a chemical booby trap that's been fooling scientists for decades. For years, this just seemed like an impossible nut to crack. But then, a new rover showed up. And this one had a very clever trick up its sleeve to finally outsmart that Martian soil. Meet our lead detective in this case, the Curiosity rover. And the key to this whole operation is tucked right inside of it. It's a miniature chemistry lab in a box called SAM, which stands for Sample Analysis at Mars. And SAM was designed to solve this exact problem.
So, what's SAM's secret weapon? It's a technique called wet chemistry. Now, instead of just baking the soil and burning all the evidence, SAM adds a special chemical liquid. This liquid very gently coaxes the organic molecules out of the soil at a much lower temperature before those pesky perchlorates can wake up and destroy everything. Honestly, the difference here is night and day. The old way was like trying to read a secret message by setting the piece of paper on fire. This new way, though, it's like carefully lifting the ink right off the page so you can read it perfectly. It protects the clues instead of destroying them.
And so, using this new trick, Curiosity drilled into what used to be a lakebed 3.5 billion years ago. They named the sample Mary Anning 3, and what it found inside was absolutely groundbreaking. This one experiment revealed the richest, most diverse collection of organic molecules ever found on Mars. We're talking complex stuff. And what's really cool is that many of them were preserved because they were locked up with sulfur. You can think of sulfur as a kind of chemical amber, protecting these delicate clues for billions of years. But the real headline, the biggest discovery of all, was a very specific kind of molecule. Okay, the name is a bit of a mouthful. Nitrogen heterocycles. But here's all you need to know. These molecules are the foundational Lego-like pieces you need to build the letters of DNA and RNA, you know, A, G, C, and T. They are the chemical precursors to a genetic system. To put it as simply as I can, this is a massive deal. For the first time in the history of humanity, we have found the raw, fundamental ingredients needed for life to arise, just sitting there in the dirt on another planet. But wait, the story doesn't end there, because in a totally different rock sample from an area called Cumberland, Curiosity found something even more puzzling. Something that looks a lot like a fossil fingerprint left behind by ancient biology. So in this ancient mudstone, Curiosity found these long-chain organic molecules, which are basically just chains of carbon atoms. But it wasn't finding them that was weird, it was the pattern of how long the chains were. Okay, stick with me, because this is the crucial part. When these chains are made by just random geology or chemistry, you get a totally random mix of lengths. Some have an odd number of carbons, some have an even number. But life is different. Biology builds these things using 2 carbon building blocks, kind of like stacking Legos in pairs. And because of that, it creates a really strong preference for chains with an even number of carbon atoms. And what do you think Curiosity found in that Cumberland rock? You guessed it, a strong, unmistakable bias towards even-numbered chains. It's a pattern that looks a whole lot less like random geology
and a whole lot more, like biology.
Now, here's the catch. Mars doesn't have a magnetic field to protect its surface from harsh radiation from space. That radiation has been blasting the ground for billions of years, slowly destroying these molecules. Now, this rock was only exposed about 80 million years ago, but still, that's a long time for the evidence to get erased. So the big question became, how much was there to begin with?
So scientists did something pretty incredible. They used lab experiments and some really complex computer models to figure out exactly how quickly that radiation destroys these molecules. And with that data, they could essentially rewind the clock on 80 million years of destruction to calculate the original amount.
And the number they got was just staggering. After they rewound the clock, their calculations showed the original rock could have contained up to 7,700 parts per million of these organic molecules. That is a massive, massive amount, way more than anyone ever dreamed they might find. So now we're left with two huge clues on the table: a truly enormous quantity of organic material and a pattern inside it that looks suspiciously like life. So could anything else, anything other than life, possibly explain both of these things at the same time?
Well, scientists tested all the non-biological explanations they could think of. Could it have come from meteorites? Nope, they just can't deliver that much stuff to one specific spot. What about from the ancient atmosphere? No, it doesn't work. Mars didn't have the right kind of atmosphere for that. Okay, what about deep geological vents? Again, no, the rocks don't show any signs of that kind of intense heat, and that process wouldn't create that even chain pattern anyway. After they ran through every known non-biological model, only one single hypothesis could explain both the sheer quantity of this stuff and its lifelike fingerprint. Now, this isn't definitive proof, not yet, but an ancient Martian biosphere is, right now, the only explanation that fits all the evidence we have. So let's just step back and put it all together. On one spot on Mars, we found the fundamental building blocks needed for life to even begin. And in another spot, we found a massive chemical fingerprint that strongly resembles biology. We haven't found life itself, but we found some of the most compelling clues in history. The real question is, what do you think it all means?